How do we estimate the value of an expansion option, a real option to expand? Hello, this is chapter 8, and the project is an expansion to another country. The company expects to receive some inflows of cash 2 years from now for about a decade, and to do that, to expand to this new market, the company needs to invest $3 million in 2 years. So the cash inflows are actually risky cash flows. There's a volatility attached to them, 25% standard deviation per year. And also in the market, a T-bill or another proxy for a risk-free rate is 3% per year. So here we have the inputs for the option. The option is a call, as the strike is a price to be paid, not received. So we can identify the 5 inputs to value the option. The strike is a fixed price, in this case, $3 million. The underlying asset is more tricky in this case because it's not directly observable. We need to estimate the present value of all those inflows of cash that are expected, and that's the asset that the company is going to obtain. In other words, if the company invests, what she's expecting to receive is an opportunity to do business in a different market or an investment project, right? That will produce those cash flows for a decade. So we need to calculate a present value for all those numbers, and that will be the underlying asset. Then volatility is quite easy, 25% per year, time 2 years. 2 years because it's time during which the company can decide whether to invest or not. This is actually an European option because she cannot exercise right now, but it has to wait 2 years and then expand to Costa Rica. Finally, the interest rate, 3% per year. So 4 out of the 5 inputs are quite easy to find. Let's now calculate the present value of the cash inflows, and let's value the call. So we're going to use Black-Scholes for this valuation. First, what is the underlying asset price? Let's work in a timeline here. The company is not expecting cash flows now nor the next year, but then 700,000 per year for a decade. To calculate net present value, we're not going to use the risk-free rate because these are risky cash flows. We use the weighted average cost of capital. So we discount at 12% each cash flow. The first discount factor is 1 divided by 1 plus the weighted average cost of capital to the power of 1. All the discount factors are the same. 1 divided by 1 plus the weighted average cost of capital to the power of the corresponding period. In this case, we are simply discounting those cash flows. So we divide, for example, 0 or 700,000 by 1 plus the discount rate and elevate it to the corresponding period. Okay, so we can simply copy the formula down and then add the present value of all those cash flows. As you can see, they get smaller. The present value of the same amount of money, 700,000, but to be received 12 years from now is smaller than the same cash flow to be received 2 years from now, of course. Okay, $3,153,000. That's the underlying asset price. Then the stock price, the strike price or exercise price is 3 million. The secret here to differentiate those two numbers is that one of them is fixed, which is a strike, and the other one has volatility or is risky, and that's the underlying asset. That's the secret to separate the strike from the underlying asset in any option, in any real option at least. Okay, 2 years, 25% standard deviation, 3% is the return, the risk-free rate of return. And now we need to do all the calculations for Black-Scholes. Then we're going to use VBA as well to do this faster. So the exponential of minus the risk-free rate, which is 3% times 2 years, the time. Now, the present value of the strike is simply the strike, $3 million, times the discount factor, which is right above. So we multiply. Then we can calculate the logarithm of the underlying asset divided by the present value of the strike. So we use natural logarithm. In Excel, the formula is simply ln. ln. And then we divide the underlying asset price divided by the present value of the strike, which we calculated in the previous step. Finally, volatility times sigma, volatility times the square root of t. So it's 25% times the square root of 2. Okay, now the two numbers, as you know, Black-Scholes formula is 3 numbers, D1, D2, and the call value. Let's start with D1. D1 is the logarithm we just calculated divided by sigma square root of t, which is, both numbers are already calculated in cells H and H8 and H7. Plus, again, what we have on cell H8 divided by the 2, the number 2. Okay, we have D1, and now D2 is simply D1 minus sigma square root of t. So we calculate the other number, D1 minus sigma, the standard deviation, the square root of t. Okay, and now we need a normal standard distribution for D1 and D2. The normal standard distribution, we can find it in Excel in the formulas, norm sdist. Remember to include the S, which means standard. And so the normal standard distribution for D1 is 0.68. That's actually the call delta. And then the same for D2. Finally, the call value will be ND1 multiplied by the underlying asset price minus ND2 multiplied by present value of the strike. Here, the call value. This is only, I'm only typing the formula in 3 or 4 steps, but that's the Black-Scholes formula. The inputs for the Black-Scholes formula are only the ones in light blue, the 5 variables. Okay, so the call value using ND1, ND2, the underlying asset, and the present value of the strike, results in $600,000, but original net present value was only 200,000 negative. So expanded net present value indicates that this project should be considered, should be taken into account as a good project. So expanded net present value finally means taking the original net present value and adding the value of the flexibility that this project has. There's a chance to expand this project with a further investment. And the option value here is significant, and that makes the original net present value to turn from negative to positive. Okay, finally, in case you, before we leave this, in case you like to include simply code for the Black-Scholes formula, make sure you save the book as macro enabled, like this, and Excel macro enabled. Then to avoid all these calculations, you simply copy the code. You can find it in the book. You copy the code. There's another video with explanations step by step about how to write this code, but just copy the code, go to the developers tab here, Visual Basic. If there's no macro here, or there's no module 1 where we should add this, what you can do is you can record a macro. Okay, stop the macro, and it will appear here. Here, modules, module 1, that's the macro we just recorded. So I will delete everything here and just insert the code for Black-Scholes. We are naming BSCall, here BSCall and BSPut, but BSCall will be the function we are creating for Black-Scholes, and it depends on the 5 variables in this order: stock, strike time, rate, and sigma. So here we can simply put all the inputs. Volatility was 25%, time to expiration 2 years, risk-free rate 3%, underlying asset price, the present value of all the cash flows here at 12% discount. Okay, and so the underlying asset price will be 3,153,000, and the strike price was 3 million. Okay, now let's try to see whether we can directly obtain the call value with the formula which is programmed using VBA. BSCall is the name we gave to the formula, and the inputs were the stock, the strike, time, rate, and sigma. Okay. And yes, I think we got the same result. So in case you are interested in that code, just go to book and copy and paste it, or watch the other video in order to program the Black-Scholes, all the Greeks, the put-call parity, etc. Okay, thank you very much. I hope you enjoy the video. Make sure you send us questions or comments in our Facebook. Thank you very much. I'll see you soon.